Okay, so our last function we're going to learn is about sinusoidal functions. Okay, so to start off, we're going to talk about measuring trig stuff. So in the past, you've only ever heard something called degrees, right? Every time we're going to talk about angles, we're in degrees. So today we're going to start you learning what a radian is. Okay, so a radian is the definition of the angle when your arc length is the same as a radius. So do you know what a radius is? So let's just pretend this radius is, what, 15 centimeters. Let's go. So this is called a radius. Then I'm telling you, if you were to go around the circle for 15 centimeters on the outside, which is called an arc length. So I can't measure that with a ruler. You guys know that? It's circular, right? I wouldn't measure it with a ruler. You could do like a shoelace and then stretch out your shoelace. But as soon as you go around the circle for the same amount as the radius, then this angle would be 1 radian. The angle is called a radian, and that's the definition of it. So have you ever heard of this before, a circumference? You've probably heard that in what, grade 7? I don't know. Circumference means to go all the way around a circle. Okay? The circumference formula is 2 pi r. So this is something you've learned in grade 7. Circumference, 2 pi r. So there's 2 pi radiuses around a whole circle. So then a whole circle is 2 pi radians. And a whole circle is 360 degrees, right? Okay, I'm running out of room here, but so if I go 2 pi radians is 360 degrees, that's my comparable. I can always say that 2 pi is a circle, so that's also 360 degrees. Okay? Are you okay if I cut this in half, just to make my life easier? So 1 pi would be worth, you know that number? What's a half circle? 180 degrees. So this is something that I use to compare between radians and degrees. Do you know in a whole circle 360, that's a big number? But radians, what's 2 pi? Well, what's 1 pi without your calculator? 3.14. So what's 2 of those? 6.28. So a whole circle only has 6.28-ish radians. So like, think about your radian numbers. They're going to be really, really small numbers. 360 is big, but radians, there's only 6-ish of them around a whole circle. So they're going to be really small values. Okay, convert from degrees to radians and draw the angle. Okay, so here we go. 90 degrees is how many radians? And what do I know? 180 degrees is pi radians. Yeah. Do you know when you set up ratios like that, what's the trick to solving ratios? What did you say? Cross multiply. So you remember how to do that? Multiply diagonal, divide lonely. So you can do that in your calculator. Multiply diagonal, divide
what do we do for that?
90 times pi. Did you find your pi button?
Yeah.
Divide by 180. You have to push yellow exponents. Did you do that? Your pi button is yellow, so you have to push yellow button first, right? Shift that button to get to the pi. I get 1.57 radians. Remember we said these numbers are going to be really small, right? There's only 6 additional circles. These numbers are small. Okay, do you see how I drew it? It says to draw it. So when you start angles, they always start from here on the side, the right-hand side. And then if you were to go 90 degrees, it's right to the top, exact top. So do you want to draw these actually? Let's do that first. A 45-degree angle. So if you start here, how would you rotate? Just halfway into that first.
Oh, I remember this in pre-house.
Yep. So that's a 45-degree angle. Now, what do you get here? So 45 is blank. 180 is worth pi. So you're going to times and divide. This number is going to be really small, right? Our last one was 1.57, so this is going to be even smaller.
Do we always want to do 180 equals pi to do stuff?
Yeah.
Yeah.
I mean, you could do 360 here and a 2 pi there, right? That's fine too.
It doesn't matter.
Yeah. Okay, 150 degrees. I'm going to draw this first. So if I go to the top, that's worth 90. If I went completely flat across here, that's 180 degrees, right? So don't do that. Would that be 150 then? Do we understand that this half is 180? So don't go halfway yet. So this number is going to be a little bigger than 1.57, right? Okay, so 150 is blank when 180 is pi times divide. .62. It makes sense to me. Why does it make sense? Because 180 is really a pi, and pi was 3.14, and I'm less than that. See what I'm connecting with in my head? So the top was 1.57, and then this sideline would be 3.14 because it's a pi. Kingston, where are you looking?
Are you doing like 150 times pi divided by 180?
Yes. Did you get something different?
I'm getting 235. That's what I'm getting.
Times pi.
150.
Times pi, yeah. Divide by 180.
Oh, yeah. There
Yeah, now it's good?
Yeah.
Do you know what happened? Okay. Ooh, 450 degrees. What do you know about that number?
Well,
You're going to go pivot 360. And what more? How much more do you have? So what should you do? you should minus that. How much more do you go past? 90 more. So when you're drawing me these, it's like a kind of like a clock arm. I need to see your like clock arm, but I also need to see your pivoting. So think about like a snowboarder. This snowboarder did a 90 degree and this did a 450. They landed in the same spot, but this one's better, right? Because they did a full more rotation in the air. Okay, so let's see what this number is. 450 is what when 180 is a pi? So times and divide. This one's going to be bigger, right? Because the whole circle was 6.28, so then I'm going to have to go more than a whole circle. Okay, and the last one. Okay, so, oh, that's past 360, so there's my whole circle. Plus, do you know how much more? 330 more, so I just subtracted that. So I'd have to do the 360 plus 330. Just get my drawing. I'm showing you I've pivoted a 360 and a 330, landed. So this number, any guesses? Don't touch your calculator, any guesses?
12.4.
12.4, I kind of like it. It looks maybe a little high. So we said one circle was 6.28, right? If we double that, right, we're going to be 12 something. So you're going to be close to 12, maybe. Should we say something close to 12? Under, but under? Does that make sense? Okay, let's see.
It's all 12.
Did you do it?
Yeah.
It's still in the 12s?
Yeah.
Oh. I thought it would be like 11 point something. So you gave me that because you'd already calculated it.
Well, I did it before you asked us not to.
I thought you said 12.4, but
Yeah. Oh.
12.04. Is that what you got?
Yeah.
Okay. That's why I thought it was a little high. 12.4 is too close. Because I was thinking this in my head. Or, sorry, 6.28 times 2. That's 2 circles. Okay, which one is larger, 3 pi or 8 radians? Okay, so convert to degrees. So this time I'm going to go 3 pi equals what? Now I'm going to write this differently because you have to line up. So now I'm going to go 1 pi equals 3/8 is 180. Do you see how I changed it? Because this is like my radian and this is my degrees. So you have to keep them on the same side. So this time, what am I doing? Timesing that. Divide the lonely. It's just vice versa of what we just did. So 3 pi times 180 divided by pi. It's 540 degrees. So I said to draw it. So I'm actually going to think about pies. 1 pi is exactly halfway. 2 pies is exactly a full circle. So where do you think 3 pi is going to get you to? 1 pi is 180 degrees, 2 pi, 360. Okay. Versus 8 radians. So 8 radians is what? I'm trying to figure out the degrees. So where are you going to line up? Where are you going to put a pi and a 180? Make sure they're lined up with each other.
180.
The 180 has to be on the degree side, right? The pi with the radian side. Okay, so there's my angle. Are we going to agree that I have to spin 360 at least, plus how much extra spin?
98.
98. So do you know where 90 is? So would you say you landed in? Do you remember your quadrant numbers from graphing? So this is quadrant 2. Okay, the question says which one was larger, so here's your answer. The first one was larger, so the 3 pi. 3 pi is larger than 8. Okay, and FYI, 3 pi is 9.42. So yeah, 9.42 is bigger than 8.